So that's mostly it for plant waste. Other waste streams from both cultivation and processing. Packaging waste is the other major waste stream, consumer packaging waste. So we have child resistant packaging laws that drive a lot of the consumer packaging waste. It's small, it's hard to recycle. Picture a joint tube. I mean, that goes here in Colorado. When I put something in the recycling bin, I put everything in the same recycling bin, my plastics, my glass, my paper, and then it goes to a recycling facility where it sorts it all. Some of it is hand sorted, some of it goes through mechanical machines and is sorted. But when you have plastics that are that small, it really doesn't sort well at the facility. It doesn't have a good recovery rate. So if I'm a responsible consumer and I actually put my packaging in the recycling bin, it has a really low chance of actually getting recycled. So what's the solution to this? Retail locations offering take back programs. That has been legalized in Colorado. Oregon has legalized take back programs. We hope other states will allow this, because then consumers can bring their packages back to the store in a collection bin. Then that bin can either be bulk recycled, it's already pre-sorted. It's a lot easier to give that to the recycling facility when it's just all the same consistent plastics. Or we're hoping to see closed loop packaging come into play here, a lesson that was, really the craft brewing industry does it great with growlers, where you purchase a growler from a brewery, if they fill it up with beer, when you bring it back, they give you, they typically actually give you a clean, sanitized one, but there's an exchange program. You get a discount on your beer. You're reusing that packaging over and over again. It also creates the opportunity for brand loyalty and giving those people that incentive to come back and get a discount or on that refillable packaging. As long as it continually meets the child resistant packaging standards and it's been sanitized and labels are completely removed, we can reuse it, which is exciting. I hope to see more of that. Again, spent solvents are hazardous waste. There's a lot of electronics and batteries, lighting ballasts, things like that, e-waste that comes out of this and needs to be disposed of properly. Those high pressure sodium bulbs, metal halide bulbs, they need to go through a lighting disposal program. Solid waste, regenerative is best. Cocoa is always a good product to use as your grow media because it's easily reusable. You can actually wash cocoa really easily too if you want to make sure there's not contamination between one harvest to the next, versus if you're, throwing out soil after every harvest. So water, again, track and trend your water metrics. People forget to do this because water is typically cheap. And it's been cheap historically for a long time. We really don't pay a lot per gallon of water when you compare that to per kilowatt of energy. As climate change progresses and our droughts progress, California's certainly seeing water scarcity. Water is going to become more and more an expensive commodity, but also don't overuse it in your cultivation just for the sake of what's good for your community. You don't want to be a huge sink for water. You're using drinking water that's treated to drinking water standards. A lot of energy went into treating that water up to those standards and pressurizing it through the pipes to even get it to your facility. So have gratitude for that and try to use as little water as possible. And that can be done with precise and automated watering. And then also think about your in-house water treatment. It's very common in cultivations for, even though it's treated up to drinking water standards, to have some additional level of treatment before it goes to the plants. When we're feeding this water to the plants, we don't want high levels of chlorine, for instance, in it. That hurts the plants, it harms the plants. So we might want to have a carbon filter to filter out some of that chlorine. We want to make sure certainly that there's no bacteria that was picked up within the pipes. But then also another high need of cultivation is we want to raise the level of oxygen within the water. Plants love oxygen. And so to do that, we can spike it with ozone, which has disinfection properties and also raises that level of oxygen within the water. Those are all good options. UV will kill any bacteria or viruses. However, my biggest gripe is reverse osmosis. There's so many people that will just right off the bat install reverse osmosis at the inlet of their facility. And what RO does is essentially zeroes out your water. It takes out all nutrients, all contaminants, But in that process, it's about 20 to 50% water to waste before you even get the opportunity to use it. It has a lot of water that just goes to brine. So unless you have a really good reason for using reverse osmosis, like if you have really high uranium or arsenic in your water, which is not common on a municipal system, that's usually if you're on well water or something like that, I say ditch the RO altogether. It's also a high energy suck as well. You can get the same plant properties from better treatment options. And then there's also just general facility upgrades that could also apply, like to retail locations. Make sure you have aerated faucets, low flow toilets, really water efficient appliances so that you're not overusing water. Best practices for air quality. I think that this is so often forgotten when we talk about any business's environmental footprint. People really don't think about air pollution because you can't see it, but it does exist. And so carbon filtration, especially for indoor facilities, is certainly the best option for air quality controls. If you can seal your entire environment and then any exhaust that you have is pushed through a carbon filter, you eliminate any contaminants. The plants emit VOCs. That's what the odors are associated with, the terpenes. So terpenes are what comes off the plants. That's what you're smelling. Myrcene, limonene, pinene, terpinolene. Those are VOCs volatilizing off the plants, and that's what the odor that you're smelling. Put that through a carbon filter. It's going to capture the VOCs in the pores. It's not going to put it out the building. It'll eliminate a lot of the odor and some of, particulate emissions and things like that too. However, to optimize your carbon filtration system, you need to keep that in mind in the design phase, because certainly if you're doing a retrofit where you have an HVAC system that was designed for the loads of human comfort, you've now stretched it to compensate for an indoor agriculture environment. It is running at max capacity 24 hours a day to fight your lighting system and the heat that comes off of it, and then the plants transpiring. I mean, it's basically taking on a jungle. What that can lead to then is when you add carbon filters, it takes a lot more energy and pressure to pull air through a carbon filter that's really porous than it does an open HVAC vent. So every new carbon filter that you add to your facility is adding HVAC load and pull to your cultivation. So keep that in mind with your HVAC system. And then also, if you're running your HVAC system at max capacity 24 hours a day, you need to really pay attention to the maximum flow rate on your carbon filter, because if you exceed that max flow rate, you're not getting proper contact time. Essentially, the VOCs don't have a chance to be captured within the filter. They're just going to blow right through, and it's pointless to have the filter, and it just becomes a high energy load. So the flow rate of the filter and the HVAC system need to come into concert, and sometimes you may need to upgrade your HVAC system to allow for carbon filtration. Never dispose of solvents through direct evaporation. Never when you're doing your extraction, let the cycle after extraction finish. It takes about 30 minutes to repressurize and basically suck the solvent back out of the plant material and out of the cylinders where it was under pressure and being washed with that solvent. It takes about 30 minutes at least to recover all that solvent out of there. If you get impatient and open up those canisters and start unloading the machine before that cycle finishes, all of those that solvent is lost and it evaporates as air emissions. You're losing money, and then usually the incentive for that is impatience. We just want to keep doing extraction run after extraction run and not understanding that our equipment has a purpose. Let it finish. Then maintain an inventory of all solvents and calculate annual air emissions. A lot of people don't know that extraction facilities actually require air permits. You are charged per ton of solvent that gets emitted into the atmosphere. So what that looks like is how much solvent did you purchase throughout the entire year? Okay, subtract out what's in your inventory. We're going to assume the rest evaporated. If you can't account for it, if it wasn't an ingredient in a product or it's not captured within your waste stream, where did it go? It evaporated into the air. So here's just a picture of what a carbon filter typically looks like at a cultivation facility. The picture on the bottom with the white kind of foam on the outside, that's a pre-filter. We highly recommend pre-filter filters in a cultivation environment, because there's a lot of pollens and dust and other things that can be captured by the pre-filter that won't gunk up your expensive carbon filter. It will save those carbon filter pores for the VOCs and things like that. It'll really extend your filter life and save you a lot in the long run, just having that pre-filter on the outside. It can also capture some of the humidity that might also gunk up the filter temporarily. There's other odor control options out there besides carbon filtration, and carbon filtration doesn't work well in a greenhouse, and it doesn't work at all in an outdoor environment. So there's chemical controls that are typically, misted at the proximity of the facility along a fan, and they're chemical spray agents essentially. Some of them are neutralizing agents, where they're actually chemically changing the structure of the terpene and making it so it's no longer volatile, and it basically just drops out of the air and chemically neutralizes it. How we chemically neutralize a VOC, though, is typically with oxidation. We oxidize it with iodine, with hydrogen peroxide. But if we are oxidizing the odor, we're also providing the opportunity for oxidation of both plants and people. That's bad. We don't want to do that. We don't want to breathe hydrogen peroxide gas. We don't want to breathe iodine particles. So really, it needs to be understood what chemical you are spraying and applying and where it is. It's not such of a big deal if you're spraying, iodine in an agricultural area versus if you're doing it in a residential area where you have, a school right next door or something like that. Then there's masking agents and counteractive agents. A masking agent's just an air freshener. We spray a pine smell, bubblegum smell, cherry smell. Your olfactory senses get overwhelmed. You don't smell marijuana, you just smell bubblegum and everything's hunky-dory. But if you look at it from a chemical level, again, as humans, we're then breathing in those terpenes and that smell of marijuana, which is benign, it's not harmful. But then in addition, we're providing that chemical odor as well. And what is that chemical made up of? We don't know. So we got to be very careful with what chemicals we spray around us. Then there's counteractive agents, and counteractive agents are a little sneaky. They can be confused with neutralizing agents very easily, because what this is when two complementary smells enter our nose at the same time, they essentially cancel each other out. This is how Febreze works. It tricks your brain into thinking, oh, I don't smell anything, because it's counteracting. But again, if you looked at it on a chemical level and took a speciated sample, you'd see all the marijuana terpenes, and then you'd see the additional terpenes from the counteractive agents. So wrapping up best practices, and since we talked about what makes a sustainable project, we talked about how to optimize energy at your cultivation. I just wanted to bring it to life with a real world example that was a great success. This project has been featured in Wall Street Journal, CNN, countless other publications, Bloomberg, you name it, and then also industry publications, Leafly, MJ Biz Magazine. It's gotten a lot of press because it's really innovative and creative. So I took my experience. I mentioned that I worked with craft breweries prior to working with marijuana operations. And back when I worked with craft breweries, one of the biggest environmental opportunities or gaps in their operation that I saw was just the sheer amount of CO2 that they generate. Fermentation, the last stage in the brewing process, which takes place in those large tanks that you can see in that first picture behind us. Those are fermentation tanks. That's where the yeasts are eating the sugars and they're creating alcohol. But as a byproduct of that process, they also generate a lot of CO2. Typically, that CO2 is just vented to atmosphere. If you've ever been on a brewery tour off of these fermentation tanks, if it's actively fermenting, you'll typically see a hose coming off of the bottom of the tank, going into a 5-gallon bucket of water on the floor. And that bucket looks like it's boiling. It looks like it's like hot water because it's bubbling. Well, those bubbles are CO2 burping out of the tank, and they put it in water so you don't get any backflow of any gases that could change the makeup of the beer. But breweries also utilize CO2. So not only do they generate it, they use it as an input to their process. When we package beer, we add in CO2. We spike it so when you open it, it gets that pop. So they purchase CO2 and they generate CO2. This to me was mind-blowing.